All right, welcome back, everybody, to the Additive Snack podcast. I'm your host, Fabian Ahlefeld, and today we are talking about one of the biggest unlocks for scaling additive manufacturing, and that is automation. For years, of course, as we all know, as we're all in the industry, additive manufacturing has proven what's possible from a technology perspective, from a production perspective. But one of the open challenges that we have not been able to tackle yet is how to automate the processes post the additive manufacturing core process. As we know, the additive manufacturing process is completely hands-off, but further down the process chain today, or in the past, I should rather say, we had a lot of manual labor involved still. And there's a company that is trying to change that today, and that is the company Grenzebach. Grenzebach is a company with decades of deep expertise in industrial automation and is now applying that experience to additive manufacturing. And with us today is Oliver Elbert. He's the head of additive manufacturing at Grenzebach and therefore the perfect person to talk to when it comes to truly automating the additive manufacturing process chain. So we'll dig a bit into who Grenzebach is, if you haven't heard about him. We'll talk about how automation is changing the additive manufacturing space and how it's also optimizing overall equipment efficiency, post-processing, even labor dynamics that I think are also very interesting in today's environment. And also we'll talk about what's next when it comes to automation. So many things to talk about. Oliver, welcome to Additive Snack.
Thank you, Fabian. Thanks for having me. And I'm looking forward to have a good discussion with you about the status of the automation in the additive manufacturing industry.
Me too. Something we haven't talked about too much on this podcast, so therefore definitely a first. And I'm super pumped to really learn more about what it takes to automate the AM process chain. Before we dive deep into the guts of automation, let's talk about Grenzebach. Can you give us a brief history lesson on the company and also how it's evolved over the decades?
Sure. Yeah. The company Grenzebach. So the company name is given by the founder, Rudolf Grenzebach. So his last name is today's company name. And he founded the company in 1960 in a lovely place called Hamla, which is in the southern part of Germany, in Bavaria, close to Augsburg or Munich. Who's a little familiar with the southern part of Germany. And
with the best and most beautiful part of Germany, yeah.
Yeah. And this small city, town, it's with 230 people living here, and during the day, 600 employees flushing into the village then. And that's where we are. And said he started 1960 with 7 employees, all highly motivated engineers, and they are working on developing and designing automation solutions for different industries. So after the foundation, 2 years later, so they had the first bigger project. So they did the automation for a dairies and a cheese factory. So totally different what we are doing today. But I said this was the start. Over the years, then business develops, and a lot of different applications, industries came into the portfolio, because Grenzebach is always looking for what's next, what can we do, where can we help serving our customers, helping to automate their processes to be more efficient, more reliable, and so therefore we started then with the glass industry. And here today we are still the provider of fully automated float lines for the production of float glass. So you have in the beginning you have the furnace, and then you have over several 100-meter length of roller conveyor systems. You have these endless glass, which is then cooling down over the time, and at the end then we do glass inspection, glass cutting, glass plates pelletizing by robots or gantries, these kind of things. And on the other side, another big industry Grenzebach is serving is the building material industry. Here we do a lot of automated solutions in manufacturing of wood plates, foot panels, isolation plates, gypsum plates, these kind of things. And here we're not talking about a single solution. We also can offer our customers complete factories. We can do the factory planning for you and also then the project management, everything. So you can buy turnkey from us.
Interesting. And is that glass for windows or different industrial applications? Does it matter?
These are mainly architectural glass. So if you look at the buildings, you can say more than 50% of all flat glasses installed in buildings have seen a Grenzebach line before.
Cool. Okay. That's awesome. Okay, so really from cheese production automation to windows and industrial goods, and you said in the 60s, right? So it's quite an old company. Typically, when you start a company in Bavaria, in the US, you started in a garage. In Bavaria, it's usually in a barn. At least that's a majority of the companies I know of. So as Grenzebach transitioned more into industrial settings, why did and when did Grenzebach decide to get into additive manufacturing?
Why? It's a good question, and the interesting part is that the initial impact to go into this industry was coming from EOS at that time.
Mm-hmm.
So in 2016, they approached us with an idea. So they had the vision of connecting printer and peripheral equipment with AGV. And also one part of our industry is the intralogistics. So we also provide AGVs and also the own. So we built the AGVs, we design also the own fleet management software and so on. And this was the first contact between Grenzebach and EOS. And the idea was then to set up a showcase, which then was presented on the Formnext 2016. And there we had a AGV from us on your booth, on the EOS booth, moving a container from A to B. And as a future outlook, how industrial automation can look like. So basically what you see behind me on the wall.
Yeah. I remember that time. And AGV, for people who don't know what that means, is automated guided vehicle. Is that?
That's correct. Yeah.
That's correct, right?
Thank you.
Yeah. So those small platforms that can move goods or logistical items from A to B without any human interaction. So 2016, so almost 10 years ago, you guys started to look into additive. But if I'm not mistaken, that adoption has been quite slow. But from where I'm sitting today, and this is not only, of course, about EOS or laser powder bed fusion technology, this really accounts for all additive manufacturing processes. The post-processing efforts are still quite manual. And somewhat recently, we're now starting to see an uptick in automation solution adoption. Why do you think that is? Why do you think it took us really 10 years in the industry to start to embrace and adopt automation solutions?
I mean, when we started 2016 and then afterwards then with the first real projects in 2017, which was a next gen AM project at that time, where we then realized this concept into a prototype setup together with Daimler Aerotech, Daimler and EOS. At that time, this was a great vision at that time. But I guess from my point of view, we were far too early with this solution, because at that time there were other topics on the agenda of the customers. So there was more than stability of the printer, repeatability, job transfer from printer A to B, print jobs development, all kind of these things. And nobody was asking where can I buy an AGV to transport my product, which was printed in the printer, to the unpacking station.
Okay.
And
so really the AM process was not productive enough where automation made enough of an impact to truly reduce cost or increase uptime, because 10 years ago, even though we already were in production and many organizations were already using additive for end-use products, we weren't at the output and productivity levels we are at today. Is that maybe a good statement?
Yeah, I would say so. So today we see is a big progress made from all the printer manufacturers. So we see larger print shop sizes, the build plates getting bigger and bigger. The number of lasers is increasing. In the beginning, we had one laser. Now 4, 6 lasers is a new standard. And of course, this also speeds up the printing time. And also in regards of stabilization of the printing process, repeatability, and the kind of things, there are a lot of evolution, I would say. And also now with the latest systems, you also have the automatic job starts. So there is no need after one print job is finished that somebody has to open the process chamber and do some cleaning of the optics or whatever. So also here, there's a big step ahead now. And this allows us now, to automate the systems, to have automated loading, unloading without having any operator on site who is doing a manual job once one print job is finished. And this also then leads to a suitable and automation solution which makes sense also for the customer, because then he connects it to the system, runs the machine. If the print job is finished during the night, job change will automatically be done by the system, or even on the weekend. So there is no more need that you have an operator on site in the night or at the weekend. Everybody has something to do at that time and does not want to stay in the factory. And
yeah, you say it so casually, right? And then the build job gets started overnight again. I mean, that is a really big step change in additive, right? That you guys are enabling. And I think you make a few good points, which is on the one hand, the hardware and peripheral equipment wasn't ready, right? The industry wasn't at a point where automated powder handling was really at a point where it could also supply a fully automated environment. There were still process challenges in the printers where you could in theory start a build job, but somebody had to clean the laser window, etc. So flow had to be optimized, and step by step we got to a point where automation is now ready. And what you say so casually makes a really, really big impact, right? Which is, if a print job finishes at 2 a.m., in the past, my only option to keep up my productivity and production was to have somebody there. So I had to run really a 24/7 3-shift model. In today's world, I don't, because a Grenzebach solution can now automatically change a frame, and the system can restart a job, which is a very, very big improvement. Can you maybe double click on that piece of equipment that Grenzebach supplies? What's the significance of a job exchanger? How does it work? And what's also then there for the impact? Maybe we can talk about that in afterwards.
Yeah, sure. So the dual setup station, so the name dual is coming from, we have 2 exchange frames in the system. So that means before we had the dual setup station, you only had 1 exchange frame in the system printer with the setup station. That means after the print job was finished, you had to wait until the job has cooled down. Then you had to depowder the job, remove the build plates with the printed parts, replace the new build plate, and then restart the system. So a lot of manual things and waiting time where the printer was idle, was not able to print because he was blocked by these other functions, cooling down, and etc. With the dual setup station now, we have 2 exchange frames in the system. And yeah, the workflow is after the print job is finished, he's leaving the printer into our dual setup station. There we then locate the build box at the buffer position for cool down. And in parallel, we introduce a new empty build box into the printer, and the printer starts the next job automatically. And then all the steps I mentioned before, cool down, depowdering, build plate removal, new build plate preparation for the next build job, everything can be done in parallel while the printer is there for what is usually dedicated printing.
Yeah.
And this, of course, helps a lot to save time and to increase the availability of the printer and the utilization of the printer. And on the other side, the other benefits you have as well, if the print job is finished during the night or the weekend, nobody has to be there, and you can restart. So that means you keep the production up and running with the system 24/7.
Super incredible. And especially also as we start to see larger print farms with 20, 30, 40, 50 machines, it starts to get really difficult to always time these machines, to always have somebody there to move a build job out and start a new build job, which also then therefore helps to reduce the complexity a little bit and buys companies some time, and therefore reduce also the necessary overhead. Do you have any numbers for us? Like, what does it mean on availability of a system before in your case, Grenzebach automation solution, and then today?
Okay. The real times, it's difficult to say because it always varies on the material you have, the print shop time.
Sure.
And so we got some rough numbers calculated by your colleagues, where we were looking on a print job with 16 hours print duration. And here we saw if this print job is done in a factory with a 1-shift model, and on the one side, and on the other side, then printer is used with a dual setup station. The output of the printer was increased by 45% over the year.
Wow. I mean, that's a big number. That's a big number.
But the number goes down, of course, if the print time is longer, then you have less exchanged cycles, let's say. So that means, as said, depends on print time, build parts, material, cool down times, etc.
Sure. For the larger and longer my build job is, the less interesting automation is, right? If I have a full 1-week build job, your impact's going to be lower. Versus if I have a 16, 12, maybe 24-hour build job, where if we talk about production applications, if we talk about applications like suppressors, for example, it's very, very interesting to really maintain that uptime and buying yourself 50% availability without having to hire a new individual and running a 24/7 shift model is certainly interesting. And it's of course interesting for not just US machines, right? This is an industry podcast, not a US podcast. So therefore, I think it's important to also mention you guys serve other manufacturers, and you also serve other technologies. Can you talk about that a little bit?
Yeah, sure. So, beside these exchange solutions, what we have now here for the US, for the Onyx machine, for example, with the dual setup station, or the exchange solution, which is connected to the P500 on the polymer side, which are both solutions which are directly connected to the printer. We also provide standalone solutions for other printer manufacturers for the depowdering and unpacking of the print shop. And here we are talking especially about larger systems with big print jobs of 600 by 600 by 600, or even a 1.5 meter height. So which takes a long time if you do the depowdering manually. And here we have developed fully automated solutions. So basically you put the build job with the box inside in our machine, and then cover closing, depowdering, unpacking, everything is done fully automatically, so that the operator then at the end just has to remove the build plate with the printed parts to the following process step.
Okay.
And this is one thing what we are doing. And then, as mentioned in the beginning, so this shared module solution, what we have developed together in 2016, and then from the prototype to the serial product, which was introduced 2019 on the Formnext as well. We meanwhile have some following projects. So we had on the polymer side, we had the polyline projects where we also developed fully automated solutions starting from the printer, where we connected the individual peripheral machines with the printer with so-called docking frames, which are mounted on each individual machine. And then we had a transport container for moving the build box from the printer to the unpacking station. And then after the unpacking station, then once the parts are separated on the polymer side, then you have to build a box, plastic box, let's say. And here we connected everything, all the machines, the post-processing with a robot cell to handle the build parts between the different stations. So we did the unpacking, the fine cleaning, and the bin picking, sorting at the end. And then we then transferred the sorted, cleaned parts out of the robot cell. And today we are again working in a government-funded project, which is called Nexamo. And here we have a similar task. So we also connect all kind of machines on the factory floor with AGVs, with robots, depending on the task, depending on the machine. And in this project, we have two different printing processes. One is the powder bed fusion process, and then on the other side, we have a DED process. So that means the customer has the possibility, depending on his build job, to select which printing process is the right one for this part. And then, of course, also depending on the print job and on the part itself, the post-process way is different. So that means you have the possibility to decide, do I need to have a depowdering, which is typically for the ED not necessary, or do you need any support structure removal? Do I need to go through a heat treatment and so on? So all this depends on which kind of build job you have. And with this setup, the customer is fully flexible. So he can, depending on the part, can then select the flow through the production.
Interesting. So really, when it comes to automation adoption in additive, today now, let's call it the new standard of automation, is very close still to the additive system, which is then the job exchange, right? How do I increase the uptime of my additive manufacturing system by ensuring lowest downtime possible after a print completed, and I move a new build frame in and start the job. And then now what you're working on, especially in these funded projects or partner projects, are then also automating the remaining post-processing chain, right? The polyline project that you mentioned, I mean, that's really interesting, where you're really talking about a polymer laser powder bed fusion process where did you fully automate the whole process all the way until a final part came out? Wow, I mean, that's really impressive. And then now you're trying to do the same thing on the metal side for DED and laser powder bed fusion.
That's right, yeah.
Wow, that's really cool. So what are the challenges there? I mean, right, you mentioned support structure removal, you have build plate, you have heat treats. I mean, it gets real complex real quick. If I remember correctly, in the past, in some of the first projects, you also then saw true robotic arms like KUKA robots, moving parts in and out of other systems. So, so how complex does it get, and what are still some of the challenges of automating that full process chain?
Yeah, it's getting more and more complex with increasing number of parts, and this is also still a challenge for the automation. So if it's getting too complex, then it quickly come to a point where the automation makes at a certain point no sense, because of course you can, in principle, you can do everything, but also the cost will increase for the solutions. And therefore, from the cost point of view, it's the most interesting thing if you have a serial product. That means you have a smaller number of different parts, and then you can optimize the production flow for these parts, because depending on what you want to do, you probably need some holders, special clips, some inserts or whatever to bring the parts in the right position and so on. And then you can fully automate this process steps. But if you have every day 20 different parts to handle, this is getting very difficult. And then you have to see, okay, which step in the product chain makes sense to automate, and where it makes more sense to do a manual step in.
And I mean, and that also goes with the trends that we're seeing today, right? I mean, we have still companies that use additive for prototyping. You're probably not going to automate that process, because every part you're printing is going to be different, or you have really low SKU volumes. Then you have the manufacturers that print highly specialized, low volume production. You could even you could put the space industry in that bucket. But now you're really starting to see serial manufacturers that are going to produce parts in the thousands, hundreds of thousands, even inching towards the millions. And I'm guessing that's then the process that you guys are really focused on, is how do we help these companies that produce one part on dozens of machines to really automate that one process chain for that one application. Does that then also, are you really thinking also about support removal, heat treats, and those types of processes that are still today very manual?
Post the support structure removal is always a big topic, where everybody's looking for the solution. So there are various solutions already on the market, but also here it depends on I think on the parts itself, and to find the right process for the individual part. Yeah, you can do this with a CNC machining. You can do this with a wire saw. You can use a hammer, do it manually. Yeah, you can add this one to the robot and do it with a robot, or you can put the part on the robot and then you hammer the part against some hard stuff, and or you use even chemical treatments or remove the parts. So that's just.
But I mean, you make a good point though. If I think about it, and especially what you said earlier, right? The technology needs to meet automation, which we also talked about with a good example is, if I have to clean the laser window, I could automate that, or I could improve the process so I don't have to clean the laser window as often, right? And we could have worked on a solution where a robot comes in and cleans the laser window, or we could just improve the process. And the same when you talk about support structures. As I say it out loud, really where we're going is applications that don't need support structures, right? If I produce a part 100,000 times, I'm probably going to design it like a suppressor and other applications that actually don't have support structures, because they are designed for the process. And therefore, it's one less thing that I need to think about automating. Is that an accurate statement that you would probably assign?
Yeah, sure. Fully agree with that. I'm just thinking about the robot standing in front of the printer waiting 20 hours to open the door and clean the window.
Yeah, or a robot with a chisel and a hammer.
Yeah, nice.
Exactly. Yeah. Okay. But then really that means that automation and additive are really converging because also both technologies are continuously advancing and are meeting each other in the middle. How far away are we really as an industry from a fully automated production environments? You probably have customers today that are thinking about that. Is that in the next 2 years? Is there still 5 years that we need to go through to really have a fully automated equipment with minimal human intervention?
Yes. As I said before, if the parts or the print jobs are well designed, as you also mentioned, suitable for less manual treatment like support removal and so on. And
Mhm.
yeah, there is a fully automated line already possible to do it today. That means, okay, we can set up a factory if necessary in, let's say, 1 or 2 years. So this is nothing special. So this is in a standard in other industries as well. So, and I
Mhm.
mean, additive manufacturing is, yeah, is it just also another production solution to manufacture parts, and CNC machining and so on, and automated CNC machines are also available today already. And it was just only a
It's
question
not
of,
rocket
doing.
science.
It's not right. Yeah.
Yeah. Okay. Do you think that I mean, especially in Western countries today, right? We see a lot of efforts, whether it's in the US, but also in Europe, of reshoring, right? We're trying to bring manufacturing back. It hasn't left as much in a country like Germany as it has left in the US, but nevertheless, it has certain aspects have left. Do you see also additive in combination with automation being more and more attractive because we are able to produce parts with less labor requirements, um, and therefore you start to see it becoming a more viable solution also for those higher volume products?
Yeah, definitely. So I think with combination AM with automation, this makes it also very interesting for Europe and the US for the production. And not only the labor cost, is also the labor or the staff availability. So if we're
Sure.
talking about production sites, yeah, not everybody is willing to jump in his blue collar dress and working 7 days in a week or 5 days in a week in a factory. Um,
Hmm.
and yeah, I think there's not only the question would be nice to. I think it's a must have in future to have most of
Yeah.
the process where it is possible to have automation solutions. So to keep up the productivity of the factory and also reduce so the number of people required for doing some, let's say, lazy, stupid jobs like moving part from A to B, because they can also be used for much more
Yeah.
productive tasks in the factory.
Yeah. And it is harder and harder to find people that really want to do that work. I'm curious to get your thoughts on humanoids. Right? I mean, you're an automation expert. In a way, you guys already deploy fully autonomous systems with your AGVs, right? Which are already replacing, to your point, workers just moving parts from A to B, which is not that much value creation for a human. Uh, What's your point on humanoids? Are they going to play a role in an industrial AM environment? Are they going to help us to also get jobs done that are not as high volume, but also lower volume? Or is it really just science fiction that looks cool?
I mean, as of today, it's science fiction. a little, but I think we are coming closer, and it's I think only a question of time once these humanoids are on the price level that it's also and functionality level that's also interesting to really do jobs in the factory. What today is done by humans because of some geometries and whatever. And yeah, I would say I personally think this is really possible in the not in the near future, not in 1 or 2 years, but in 5 to 10 years. I think we will see factories where we see moving robots.
Very interesting. It's interesting times, not just in additive, but in manufacturing. The tides are changing. The technology is changing. And as we said earlier, right, as additive becomes highly mature and automation continues to expand, we'll see, I think, you and I, but also all of us in the additive manufacturing industry work very, very closely together. Oliver, it was awesome to have you on the show. Really excited to talk about automation and learn more about it. I think this is just the beginning. Probably 5 years from now, we're gonna look back and really scratch our heads how we could be printing parts without any automation equipment in the back end. So really excited to see more from Grenzebach, more from you, and more from this collaborative industry convergence. So thanks for being on the show.
Thank you, Fabian. It was a pleasure.
And yeah, thank you out there for tuning in. If you want to learn more about automation, make sure to also check out Grenzebach. Make sure to reach out to Oliver or myself if you have any questions. Comment on YouTube or your favorite podcast platform. This was the Additive Snack podcast. I'm your host, Fabian Allerfeld, and I will see you next time.